Have you ever really thought about what's in the food you're eating? I mean, not just the stuff on the ingredients list, but the things you can't see, taste, or smell. Well, today, we're going to pull back the curtain on the amazing, invisible science that's working around the clock to keep us all safe.
Okay, so let's get right into it. Think about the apple on your counter, or that cup of tea you just made. Every single thing we eat has a hidden story, and sometimes that story includes some invisible secrets. We're talking about tiny, unseen contaminants that could, potentially be harmful.
So yeah, that's the big question, isn't it? How can we be so sure that what we're about to eat is actually safe from these hidden threats? Well, the answer isn't magic. It's some seriously clever science. And what exactly are we looking for? Well, it could be all sorts of things. We're talking about trace amounts of heavy metals that get absorbed from the soil, maybe some leftover pesticide residues from farming, or even too much of something that's naturally there, like fluoride. A little fluoride is good, sure, but too much can lead to some pretty serious health problems. To hunt down these invisible culprits, scientists have these two incredibly powerful techniques that basically act like highly specialized chemical detectives. They're called voltammetry and potentiometry. Kind of sciencey names, I know, but trust me, what they do is super cool. And this is a fantastic way to think about it. Imagine voltammetry is like a chemical stress test. You're poking the sample with electricity to see how it reacts. Potentiometry, on the other hand, is way more chill. It's like a chemical thermometer. It just measures the existing electrical state of a specific particle without forcing any big reaction.
Okay, so we've got the simple version down, but you're probably wondering, how does this stuff actually work? So let's get a little more into the weeds and look at the mechanics behind our chemical detectives.
First up, voltammetry. So the basic idea is that you're zapping a solution with a changing voltage. As you do that, certain chemicals in the solution will react, and that reaction creates a tiny electrical current. That current is exactly what the machine measures. And the process itself is pretty straightforward, really. You just dip 3 electrodes into your sample, then you apply a very controlled, varying voltage, and finally, the machine measures the current that's produced, which gives you this unique graph. It's called a voltammogram that acts like a fingerprint telling you what's in there and exactly how much. All right, now for our other detective, potentiometry. Now, the key phrase to remember here is without drawing significant current. Remember, it's not trying to force a reaction like voltammetry. It's just passively measuring the existing voltage between 2 special electrodes. It's like it's just listening in on the chemical conversation. So, let's just put it all together. Voltammetry measures the current that comes from a reaction, which makes it incredibly good at finding super tiny amounts of things like pesticides or trace metals. Potentiometry measures a stable voltage, making it the perfect tool for specific ions like fluoride, or for measuring something like pH. It's all about picking the right detective for the right case.
All right, enough with the theory, right? Let's actually see these detectives in action. We're going to open up a couple of real-world case files and see exactly how these techniques uncover hidden toxins in the food we eat. Our first case involves tea. Now, tea plants are really good at absorbing fluoride from the soil. And like we said, too much of it can be a bad thing. So how do scientists check the levels? You guessed it, they bring in our thermometer detective, potentiometry. So the lab preps the tea sample, they use an electrode that's specially designed to detect only fluoride ions, and they get a reading, 108 millivolts. Okay, so what in the world does that number even mean? Right now, it's just a clue. Well, to crack the case, scientists compare that clue to something called a standard curve. It's basically a pre-made chart from samples with known amounts of fluoride, and by doing that, they can translate 108 millivolts into a very precise concentration, 2.46 milligrams per liter. And just like that, case closed. And this is where the data gets really powerful, because you can start comparing different sources. So, tea from region A has that 2.46 level, but look at this. Tea from region B is way higher, at 3.54. This is exactly the kind of hard data that regulators need to make safety decisions. Moving on to our next case file, pesticides in corn. We all know that long-term exposure to some pesticides is a major health concern. So this time, we need our stress test detective, voltammetry, because it's just so incredibly sensitive to these kinds of compounds. So the lab takes the corn sample, extracts anything that might be in there, and runs the analysis. The voltammogram pops out, and it shows a peak current of 4.5 microamps. And once again,
This is our raw clue from the scene.
And you know the drill by now. They take that clue and use a calibration curve to figure out what it really means. That 4.5 microamp reading translates directly to a pesticide concentration of 0.300 milligrams per kilogram of corn. That is an unbelievably tiny amount, but Voltammetry finds it, no problem.
And here again, the data lets us make these critical comparisons. Corn from region B has more than double the pesticide residue of region A. This is the information that helps make sure that the food on our shelves stays well within safe limits.
So we have the science, and we have the data. But these numbers don't just sit in a lab report somewhere. They're a really important part of a much bigger system, with people and organizations all working together to protect our health.
Think of it like a chain of information. It starts with the lab scientists running the tests, then it goes to toxicologists, whose job it is to figure out what those numbers mean for our health, and finally, all that info gets to regulatory bodies like the FDA or the EPA, and they use it to set the safety limits that protect all of us. It's a massive team effort, for sure.
So, the next time you pour a cup of tea or bite into an apple, just take a second to think about the incredible chemical detectives working behind the scenes. It really makes you wonder, doesn't it? What other invisible science is out there quietly protecting you every single day in ways you've never even imagined?